All right. So now we're doing FreeCodeCamp Legacy Python for everybody. Intermediate strings. There we go. Just finished. Well, actually, it's uploading right now, the dice game video. And so now we're back to Python. If you're watching this in order, maybe you didn't even notice. All right. That being said, we've got our notes right here, and let's go. All right. Turn the volume down. I almost forgot. I did forget. All right. And we're also going to type this out. Slicing strings. All right. We'll do that. So let's get the notes out. Go all the way to the bottom. And we'll start with this one. We'll say slicing strings right here. All right. Slicing. Nope. Slicing strings. So we can also look at any continuous section of a string using a colon operator. What? What? Oh, this? Oh, yeah, it's not JavaScript. Okay, yeah. Okay. So we've got this right here. We can see Monty Python is going to be 12 letters, 12 characters, I should say, including this space. And then it starts at 0 and goes to 11 like that. And then we're going to, each one of these letters is at that index reference point, whatever you want to call it for Python. Let's do the next thing. The second, and we'll go over this one in a second too, because I've never really seen this before. The second number is one beyond the end of the slice. So it's up to, but not including whatever. All right. So it's just like slice in JavaScript where it's the last number is not inclusive, right? So 0 through 4 is going to go through. It's going to print 0, 1, 2, 3, but nothing after that, right? And then we can see right here, Mont right there. If the second number is beyond the end of the string, it stops at the end. All right, let's type that out. If the second number is beyond the end of the string, it stops at the end. Okay, true. Why would it be 6 though? Oh, it starts at 6. Okay, I see. Okay, so let's get these in there, right? Let's do this. How about that? Let's type it over a few and say let's say it up here on this line. Let's say S equals Monty Python. All right. Let's come down here. We'll say print S, and then we'll do this, and we'll do this, and then inside of here we'll do 0. Come on. No look. That's why it's like this. 0:4. All right. So when we do this, it's going to print out. Let's do this. It prints out Mont. Let's do 2. All right. Prints out Mont. All right. We're going to come down here and we'll say print. Let's do this. Let's do this. Not that. And then let's do S in front of it, and we'll say 6 to 7. All right. So this is basically how we're slicing, I guess. We're just going to put S instead of slice, and then we'll put like oh no. S is the variable name. Okay. So yeah, this is S from 6 to 7. Okay, so 0, 1, 2, 3, 4, 5, 6. It's just going to give us the capital P. All right, so let's do that. And let's do this. Well, no, we can't do that. Let's do this at least. Copy that, come down here, tab it over, drop it off, and then we'll say print S 6 to 20. It's just going to print out Python because there's nothing after 11. All right. So that's basically how that works. Let's hear him talk about it.
Now we're going to dig in.
Whoa.
So now we're going to dig into strings a bit.
Right.
And we've already looked at how you can pull out a single character in a string. And now we're going to look at what we call slicing, and that is pulling chunks of a string out. And again, we're going to use the square bracket operator. And so S, and the way I say it is sub. S sub 0 through 4. That's how I read this. S sub.
Yeah, he says sub. I always say at. Sub-Zero, like Mortal Kombat, you know, that's probably where they got it, because Mortal Kombat is an American fighting game, right? So that's probably where they got the name Sub-Zero. You know how they do. So let's keep going.
Sub 0 through 4. So I look at the colon as through. I look at the brackets as sub. And so S sub 0 through 4 says start at position 0.
But it's not through. That's the thing. It's not through 4, because through 4 would mean stop here. It's to 4, right? 0 to 4, right? And it doesn't do 4. Hopefully that makes sense. Let's keep going. That's why I say at. I don't say sub. I say S at 0 to 4. You know, maybe, you know, you can say, that's the thing. I've said it before, but the thing about coding is that coding is new and it's not standardized. Okay, so everybody's just making up whatever they want. All right, and that's what I'm doing too. I don't say sub 0 to through 4. I say at 0 to 4, and that's because that's just how I feel like saying it, and it makes sense to me. But whatever, you say it however you want. There is no law of how to do this. It's just except for like machine code. All right, let's go.
And then go up through, but not including 4, right? So we don't include 4. So that's probably the hardest part of this. Up to, but not including. Up to, but not including. This seems counterintuitive, kind of like starting at 0 seems counterintuitive, but after a while, you get used to it, and there'll be situations where you're writing code like, oh, that's why that works better. But just for now, remember it. Up to, but not including. It's just kind of a little thing.
True.
We'll come back to when that is.
Although I haven't figured out why it's like that, but you know, it really doesn't matter, because even if you know why, you're still going to have to do it. And even if you don't know why, you're still going to have to do it. Why do we breathe air? Oh, scientific, because of oxygen and oxygenating the blood in the bloodstream and X whatever, but you don't need to know that to breathe. You get what I'm saying? So let's go.
Useful for us. 6 through 7, well, that ends up being starting at 6, up to, but not including 7. So that's why we only get the P out. Now, one thing that Python is pretty nice about is it's not going to give you a traceback. We might expect that 6 through 20, well, there's no 20 characters, but it's like, that's okay. We'll just let you stop at the end, and we'll start at 6 and go all the way to the end. Oh, no traceback. It's almost disappointing sometimes when Python doesn't trace back, when you think, if you're so obsessed about everything, I would have traced back in that situation. But hey, I guess if you're allowed, you're allowed. And so there we go.
There we go.
Now you can.
All right, so let's put this one down. If we leave off the first number or the last number of the slice, it is assumed to be the beginning or the end of the string, respectively. Okay, makes sense. All right, so let's put that down. And then we'll type these out while we're at it. All right, so if we leave off the first number or the last number of the slice, comma, it is assumed to be the beginning or end of the string, respectively. All right, we use that word enough to know what it means. So we'll come over here and we'll do that. We'll say print. Actually, let's get this. Let's do this here. Copy it, drop it. All right. And we're going to do that 3 times. So let's do it 3 times. All right. And boom and boom, right? So this first one is going to be 0 to 2. Not 0, blank to 2. All right. So it's going to say 0, 1, 2. So it just gives MO, right? So we'll say MO right here. M-O, Leslie, right? So now we're going 8 to blank. So 8 to blank. And that should be 0, 1, 2, 3, 4, 5, 6, 7, 8. So thon. All right. So let's get rid of the pi and just give it the thon, just like that. All right. So we've got S blank on blank, S at blank to blank. It'll give us Monty Python. But you know what? What's it do when we put nothing in there, huh? Isn't that a good question? How do we test that? Should we open up this thing? I think we should. I think we've got this right here. How about that? I don't want to do that. Let's just see if he talks about it. All right. Because I don't want to figure it out in the middle of the video. You know, I should have, if I rehearsed it, we should do it. Right. But I didn't. So let's go.
Eliminate or omit the first or last. If you eliminate the first, it assumes the beginning of string. If you eliminate the second, it assumes the end of the string. And why you would do this, I don't know, but that's from beginning to end, so it's the whole string. So whole string, 8 through the end is thon, and up to but not including 2 is mo. All right, so you get that. So that's pretty simple. Once you've got the rest of slicing and the rest of string indexing, the notion of eliminating the first or the last of the colon expression, the first or second of the colon expression, I think is actually pretty intuitive, pretty nice. All
right, so let's do this next thing. String concatenation. We know this, but we're going to type it out anyway. All right, so let's go down here and say string concatenation. Let's go see if I spelled that right. Concatenation. All right, looks great. So when the plus operator is applied to strings, it means concatenation. All right, we know that, but let's type this down anyway. So we've got this here. We'll start here on this line. And we'll say regular equals hello. All right, let's tab it over. We'll say B equals A plus there. All right, so it's concatenate. When we say print B, we're going to get hello there in camel case, upper camel case. If we have C equals A plus a space plus there, and then we do print C, it'll give us hello there in title case. All right. And I don't know what that last part is. Maybe he just forgot to edit it out. All right, so let's watch.
Been concatenating strings together. We overload the plus operator, and there is no space added. Remember, when you're doing print x comma y, this comma does turn into a space, but that's not what's happening here. There is no automatic space being added, and so we see hello in there, and it just is hello there with no space. And so if we want, we just have to concatenate the space explicitly.
True.
If we want to put spaces into strings. The problem is if this, you might think it's more convenient to add a space with a concatenation, but then you have to think, well, what about if I want to concatenate things and not put the space in? Then I'd need a different operator. So that's kind of why it works that way.
Okay. Let's do this using in as a logical operator. So this is something that we don't do in JavaScript often. I don't even know if we did it at all. So let's do this anyway. Using in as a logical operator. Using in as a logical operator, right? The in keyword can also be used to check to see if one string is in another string. Okay. What else we got? The in expression is a logical expression that returns true or false and can be used in an if statement. Okay, so let's type this stuff out. So fruit equals banana. Is this what we do? Hold on. Nope. Oh god. Come on. All right, let's do a Control X. Control V. Oops. Control V like that. No. Yeah, we would do that. Control V. Backspace. Not backspace. Delete. Tab. All right. Okay. So that's more like what we usually do. All right, so let's do this. We'll tab it over and we'll say fruit equals a banana. All right. Then we've got in fruit. So that's going to be true. It's not going to print out true, but it's going to be true. Okay. All right. And so if we do, let's do this. Let's grab this. M in fruit, it's going to be false. All right. False. Okay. Nan in fruit. Oh, because it's got banana. Okay, cool. Yeah, so let's do that. I was almost confused on that. Let's drop this off. Nan in fruit. It's true because there's N-A-N right there, right here. All right, what else? If A in fruit, print found it. All right, so we can do that as well. All right, if A in fruit, all right, I'm going to tab it over, print found it. Okay, and there we go. And then it's going to print found it like that. Okay. Or should we bring this up? Let's bring this up and see if it looks cooler. Nope. Well, let's do it right here. Okay, great. So hopefully that makes sense. I'm sure it makes sense. So that's what it's going to do. If there's an A in fruit, which there are 3, we will print found it, and it prints found it. Okay, so that's basically how that works. Let's listen to him talk about it.
We can use in differently as a logical operator. So we're using it as an iteration structure in for loops, but we can also use it as a logical operator in if statements. So it's kind of like the double equals or not equals or less than or equals or something like that. It's like those guys, and so. And it returns a true or a false. Is n in fruit? So that's a question, and the answer is true. Is m in fruit? No, that's the answer to a question. Is nan in fruit? Doesn't have to be single character, can be more than one character, and the answer is true. And then you say something like, if A in fruit. And so this is the logical value that returns a true or a false. And yes, we found it. So that becomes true in this particular case. So it runs the little indented bit. So in is an operator in this particular situation. In a for loop, in means something different. And we'll use in for other things as operators, as logical operators coming up in a bit.
Okay, before he goes to the next slide. So right here, he said is in fruit, but we can't say it like that because the answer to is, to closed-ended questions like that, is or are or whatever, is always yes or no. But this is more of a statement. In fruit. In is in fruit. True. M is in fruit. No, it's not. The computer's saying, no, it's not. False. That's false. This is true. Nan is in fruit. Yes, true. I agree. So it's not like it's answering questions. It's just agreeing or disagreeing. You get what I'm saying? And then and then this just does like what it tells you. You're saying if A is in fruit, print found it. Okay, found it. And it doesn't even say okay. It just does what you tell it. All right. So just to let you know, we're not really asking computers anything. We're just telling it things, and it says yes, no, pardon me. It says true, false, okay. So there we go.
Yeah.
And let's type this down. All right. Grab this. String comparison is what it said. String comparison. Okay. So we'll do this. We'll tab it over and say if word double equals banana. Okay. We're going to print for some reason we're going to print all right, comma, banana and us. All right, period. For some reason, I don't know why we would do that, but we can if we want. All right, so we've also got this. We're going to do, since this is going to be an if with an elif, we're going to put this space in between, right? So we'll say if word is less than banana. Okay. What we're going to do is we're going to say print. Oh, goodness. Your word. Let's get all this punctuation done first. Space, space, plus, space, another set of what are those called? Quotes, and then found it. Oh my god. Okay. I was just pressing what I thought would work. All right, so we've got that. So in this first one, we're going to put your word, all right? Your word, comma, word. Where did we we haven't even declared word yet, but whatever. Comma comes before banana, okay? Period. elif. And then we're going to do elif word is greater than banana. Okay. We'll do this. Oh, I should have copied and pasted it. Well, whatever. Paste this. All right. Your word comes after banana. All right. And then else we're going to do this. So we'll say else. And then we'll do this right here. All right. So that's basically it. So I don't know if we've discussed how UTF-16 works, but like this, according to the UTF-16 character list, which is just all the characters in order, all of them given numbers, B is its own value. Like it's like, I think it's like 92 or maybe 60 something. I don't know what it is, but it's like, it's got a number involved in, and the A, lowercase a, has the number right before B. Okay. So like, this is just like if it was a number and it was like 1, 2, 3, 1, 2, 5, 7, whatever. Right. If it's greater than, it's 1, it's going to be this. And if it's less than, it's that. Right. Hopefully that makes sense. Let's get to it. Hopefully he explains it a little bit better than I did.
You can compare strings, and this has to do with the character set of your computer, the character set that Python is. But in general, it is lexicographically less than and lexicographically greater than. Uppercase and lowercase are a little weird. I think when we used the max function earlier, the way my computer was set up, uppercase was less than lowercase, but in general, uppercase is less than lowercase. But in general, it's bad to assume case, but there is a deterministic way to sort strings. You can, have something equal to or less than or greater than, and all those operations work naturally. The less than and greater than, you have to kind of be aware of uppercase, lowercase, things like where punctuation sorts less than or greater than letters. That's kind of unpredictable and depends on the character set of your computer.
I wouldn't say it's unpredictable. You have to know the character set. That's what he's talking about. Like the character set is like, okay, like let's say UTF-16. Let's go pull that up. Why don't we do that while we're here? And I mean, okay, UTF-16 list. Boom, right there. So we've got this right here, all the characters for UTF-16, right? You see, these are the characters. We've got all these boxes. We've got the numbers. Capital letters start at 41, and then lowercase letters start at 61, right? And then there's these punctuations, but I don't know, maybe the UTF-8 list is different. UTF-8 list. Let's see. So we come down here and A starts on 41 is the same, I guess. And then this one starts at 61. So it's the same. I don't know what he's talking about, honestly. Maybe there's even more character lists than UTF-16 and UTF-8. I don't know. We'll see. So let's get back to it.
Computer, and something you just play with and figure out if you're doing sorting stuff by first name and last name, as long as the case is kind of the same. If you were sorting Chuck with an uppercase and Glenn, the fact that these uppercases, they'd sort right and these lowercases would sort right. But if you were to subdue instead lowercase Chuck and uppercase Glenn, then that would sort weird. As a matter of fact, the G would come before that. And so case can mess this up. But in general...
Yeah, but all you have to do is change this to all lowercase, or this to all uppercase, and this to all uppercase. One of the two, and then it works fine. I mean, this is a very simple, easy, elementary problem to have in coding, but it's so easy to fix. All right, but let's get to it.
Well, other than case and special characters and other things, it technically works. It's just hard to kind of predict it.
All right, let's knock this out. It's 29 minutes, 6 minutes. Is this going to be an hour and a half? Do I got time to go do something else? Oh my goodness. Is this going to be an hour and a half freaking video? String library. Let's do it. String library. Python has a number of string functions which are in the string library. Okay. Let's see. These functions are already built into every string. We call them by appending the function to the to the string variable. Okay. These functions do not modify the original string. Instead, they return a new string that has been altered. Okay. Okay. All right. So let's do this. All right. Let's get it over here. All right. So we're going to say greet. Greet equals hello, Bob. Hello, Bob. Okay. And then we're going to have zap equals greet dot lower. All right. So that's going to print. So when we print zap, okay, it's going to print out hello, Bob, like that, turning everything to lowercase. Okay. So that's how we do the lowercase in Python. Whoa. Hello, hold on. Okay, hello, Bob. All right, let's come down here. So the next thing is print greet. Print greet is going to give us capital hello, Bob. One of these days, whatever. Hello, Bob. Let's keep going. Then we'll say print hi there dot lower. So print, and then we'll have the string. Oh, give me a second. Hi there, and then we'll say dot lower. All right. And what this is going to give us is hi there in lowercase, right? Because I mean, it's the same thing. When you say greet equals hello, Bob, it's the exact same thing as if it said hello, Bob in here dot lower. So it's a string dot lower, exact same kind of thing, right? So just letting you know on that one. Let's go through this one.
What we do is use the string library. And so the strings are objects, and we'll talk later about what that really means.
True.
And objects have these things we call methods.
Also true.
So a string object has some built-in capabilities, and one of the built-in capabilities that the string object has is, here is a string object, and because greet is a string object, if we said type, we'd see that it was an str. Dot lower says, hey, dear string, make a lowercase version of yourself.
It doesn't do anything.
It's like calling this function lower and passing greet into it, and then give that back to me. Now, it doesn't actually change greet. It gives me a lowercase copy. So here I have hello, Bob, with an H and a B uppercase, and what I get back in zap is hello, Bob, all lowercase. And note that greet is unchanged. So hello, Bob is still there. And you can even call these methods on constants. So this is a string object, quote, hi there, quote, dot lower. That says, call lower on this bit of string and give me back a lowercase version of it. And so it prints out as the residual return value. This is like a function call, but a method call is a kind of special form of a function call.
Yeah.
It's a function call where you say the thing dot the function name rather than function name passed in as a parameter.
True.
Like len, for example, is non-object oriented. You know, len of x, that's non-object oriented. Object oriented would be x dot something, parentheses.
X dot length.
But So constants are objects as well, and taking the lower gives us back lowercase hi there.
True.
And so that's just one of the things that you can do in the string library. These are built into string variables and constants.
I'm sure
they're just always there. As soon as you make a string, they're part of it.
Okay. I'm going to have to interrupt right there. So yeah, let's look that up. I'm sure there's actually a string library we can look up. Let's say Python string library. Python string library. Let's see. Common string operations. Okay, so we got string.ASCII letters. It's the concatenation of the ASCII lowercase and ASCII uppercase constants described below. This value is a non-locale dependent. Well, I don't know what that means. All right, so we got all kinds of stuff right here. Custom string formatting, we can do stuff. So yeah, here's this. This isn't what he's talking about at all. Python built-in methods. Built-in methods. All right, I guess it's still the same. Okay, so yeah, what were we just looking at? Dot lower? There should be a lower, right? Nope. These are built-in functions. Where's the methods, bro? Python built-in Python string library. String methods? We have to figure this out, guys. Built-in types? Is that what you guys are saying? No. See, that's another thing about okay, so here we go. We got lower, upper, title, swap case, capitalize as some methods. And then we've got a lot more methods going on as well. And these are just for strings. There's probably array methods too. But we'll get, not array, but list methods. We'll get into that stuff later, hopefully. So let's get back into it.
And when you do type and it says it's class str, we'll get to object-oriented. Don't worry. We'll get to object-oriented.
We will get there.
Okay, and so you can...
What? All right, let's just look at this. We don't need to type all this nonsense. All right, so stuff, hello world, type stuff, class string, dir stuff. Okay, lower. Okay, so maybe when we do dir stuff, these are all the different things we can do, like capitalize, case fold, center, count, encode. We can do any of these just like, let's get that. Any of these just like this dot lower. So we could say dot r partition, dot r split, dot strip, dot swap case, whatever, right? So let's see him talk about it. I think that's what's going on.
You can do things like use the type. If you're just, look, this used to say type stir, but it's class stir. Kind of, this is more of an the word class is an object-oriented concept, but it is a string, and you can use the dir, and of course there's extra stuff up here, and this is showing all the different methods or capabilities, things we can do to strings. So, you know, x dot something, parenthesis. Well, what can we do there? This is all of those things that we can do to x's that are built in and come with x's, come with strings when we build them. And Python, of course, has great documentation online for all of these string methods and what they do and how they work and why they work the way they do.
Is it great, or is it just a mishmash? It's all there, but it's hard to get into. I don't know. All right. So we're going to go into this in a second. I'm going to take a coffee break because this is going to be a long one. So I'm going to take a coffee break and be back later in just a second. It's going to, anyway, you know how videos work, right? So see you in just a little bit. All right, I'm back. Should have just kept it recording. Now I got to resync the audio to this again, but whatever, no big deal. It's not your problem. Let's go.
These, but you know, so here's string methods and what they do and how they work and why they work the way they do. And so here's some of that Python documentation. We'll look at a few of these.
Yeah, we're not going to write this down because this is all, I guess, on the Python site. But anyway, here's string.replace. And for the parameters, we've got the old string and then the new string. Oh, what? And then we're going to have something comma count. What? All right. It's going to return a copy of the string with all occurrences of substring old replaced by new. Okay, so whatever it used to be, it's going to be replaced with this. If the original argument count is given, if the optional argument count is given, only the first count occurrences are replaced. What? Okay, so we have to have a comma, we have to have brackets, a comma, a space, and a number for this count to be counted, I guess. I don't know. We might go into this later. So we've got string.rfind. We've got the substring, and then we've got start end. I wonder if these commas are for real. All right, I don't know. We'll see. So return the highest. It returns the highest index in the string where substring sub is found, such that sub is contained within S start and end. Optional arguments start and end are interpreted as in slice notation. Return -1 on failure. Okay, well, anyway, he's going to go through these maybe. Because the thing is, I usually only look this stuff up when it's time to use it. You know what I'm saying? Not just like, oh, you know what? I'm bored. I'm going to go read about our index. Anyway, so let's go.
But, don't hesitate to say Python string uppercase. And then I'm like, oh, yeah, that is upper, right? And so here's a few things that we can.
So, yeah, we're not going to write this down either. But here's some things. We got capitalized. I think it's going to capitalize all of it. I think it's maybe the same as upper. I don't know. Maybe it only does the first letter. I don't know. String.center with comma fill character. All right, let's let him go over it.
And do and use some of the ones I use a lot, and we'll look at each one of these things. So the find operation.
I guess we'll look at them later. All right, so let's type this down. Searching a string. All right, let's get this. Searching a string. Okay. We use the find. If you ever see this, these afterwards, it's usually a method. Sometimes it's a function. It all depends. But if it looks like a built-in method, it's probably a method. So we use the find method or function, whatever function, to search for a sub. It's totally went against what I just said. Anyway, so I guess this one's a function. So we use the find function to search for a substring within another string. Okay. The find function finds the first occurrence of the substring. Okay. If the substring is not found, the find function returns -1, okay? And we're going to remember that string position starts at 0. Okay. So let's do this. So we'll bring this over. We'll say fruit equals banana, okay? Oops, not like that. So we've got point of sale equals fruit.find, and then we'll say inside this nah. And when we print point of sale or position, I guess that's what it is, position, print position, we'll say 2, okay, because that's where the first A is. All right, so now we've got this, and we're going to say print AA, and that's going to give us -1, because that's nothing. Wait, what? Hold on. That's not what we did. We're going to say AA equals fruits.find. And then inside here, we'll go Z. There's no Z in bananas. So it's when we say print AA, it gives us none. No, it's -1. -1. All right, so there we go. Let's see. Let's watch this.
Says, find me a substring within a string, right? Find me a substring within a string. So find me the first NA and give me back the position. So that gives me back 2. And then...
Were we looking for NA or A? NA. Okay, yeah. So it goes to 0, 1, 2 like that. All right, let's go.
And I can say, go find a Z in there. Well, there's no Z, and so it returns me -1. So that's what the find does. So we're going to use this kind of stuff a lot, and we do a lot of looking in strings. Converting things to upper.
All right, so let's do this one. Making everything uppercase. So making everything uppercase. I guess that's how we're doing it. Uppercase, like that. All right. So we can make a copy of a string in lowercase or uppercase, okay? Often, when we are searching for a string using find, we first convert the string to lowercase so we can search a string regardless of case. True. All right. So let's do this. Let's bring this over. Let's say greet equals hello Bob. Okay. And then we're going to say in equals greet.upper. Okay. So when we print print in, we will get hello Bob, like that. All right. If we say www equals greet.lower, that's not how we do it. Greet.lower. All right. And we say, come on now. When we say print www, what we'll get is hello Bob, like that. All right. So yeah, that's it. So we can make a copy of a string in lowercase or uppercase. True. Often when we are searching for a string using find, we convert the string to lowercase so we can search a string regardless of the case. All right, makes sense. So let's watch him talk about it.
Upper or lowercase, there is an upper method and a lower method. So greet.upper, and that means the uppercase NNN is hello Bob. Greet.lower, that means that www is the lowercase hello world, and greet is unchanged. Greet is still hello Bob with upper and lower, because each of these methods basically say, I'm going to give you back a uppercase copy or a lowercase copy of the original thing without changing the original thing.
True.
Search and replace is super useful. Super duper.
Yeah, also very useful. So let's go through that. Search and replace. So search and replace. All right. So the replace function is like a search and replace operation in a word processor. Okay. It replaces all occurrences. Is that right? God, this is stupid. Okay, there we go. All occurrences of the search string with the replacement string. Okay. So let's go up here and let's do that. So greet equals hello Bob. We got that. Come on. Just give me a break. Just let me do this without too much work, please. All right, hello Bob. We've got no string in str whatever equals greet dot replace Bob oh my goodness, with Jane. Yay. I don't know if this is taxing as much as it's very tedious. We're going to print no string, NSTR, but it's good practice, isn't it? All right, so this is going to give us hello Jane like this because we replaced, well, we're not even printing out greet. All right, so we got that. And then we're going to say, whoops. Let's do this. All right. Now let's do this and let's do this. So now we're going to say in str equals greet dot replace O with capital X. All right. So what that's going to give us is anything that's an O is not going to be capital X. So we're going to say, when we say print in str, we're going to get hell X BXB. All right, that's just stupid. But whatever. All right. Whatever. Anyway, coincidence? I'm sure not. Anyway, so let's go.
Very useful. And it's pretty clean. Here we have a string.
You've seen the 666, bro. You've seen it earlier videos. They can't help themselves. I'm telling you. They cannot help themselves. They want to do it as much as possible. And the thing is, when you meet these people, they've got like arms the size of Red Bull cans, you know? They're never anybody you want to actually know. You know what I'm saying? Let's go.
Method, in this case, we're passing in the old and the new. Bob, replace all Bobs with Janes. And so that takes this hello Bob and turns it to hello Jane. Again, greet is unchanged. Greet is unchanged. And it does more than one thing. So this says go find, well, let's clear that. This says go find all the O's and replace all the O's with X's. And so it goes and finds two of them, and then out come two X's. And so that really is replace is not just replace the first one, but replace all of them. White space.
All right, let's do this. Stripping white space. Okay. Let's knock this out. All right, stripping white space. Okay. Sometimes we want to take a string and remove, hold on, move my little filter, my little pop filter, and remove white space at the beginning and or end. Okay? I believe it. I strip, and is that L? Okay, L strip. L strip and R strip. Remove white space at the left or right. Okay. And then strip like this removes both beginning and ending white space. Okay. So let's do this one. All right. So greet now equals and then we'll have space, whatever. Hello, Bob, space. All right. So a lot of white space. And then we're going to say greet.lstrip now, and that's what it's going to make. It's not going to print it out because we didn't tell it print, but what it's going to do behind the scenes is say hello, Bob, and then have the rest of the spaces on the right hand side. When we do the same thing with, let's take this, with our space or our strip, it's going to cut it down on the other side, all right? So yeah, it's going to look like that. And then when we do what? But the thing is, like, it didn't like leave it like that. It doesn't leave, so it doesn't actually change greet. Okay, so it doesn't actually change greet at all when it does this. So this is this, and this is this, but greet stays this the whole time. Okay, so that's something about Python. Greet.strip is going to give us regular old hello Bob with no white space on either side. All right. So there's that. Let's listen to him talk about it.
C is a big deal. And white space is not just blanks, although the most common thing, but it's also sort of non-printing characters like tabs and new lines and other kinds of things. And so we have a number of different ways to strip white space. So here we've got some spaces at the beginning and spaces at the end. And we print out, we do an L strip, and that throws away the spaces at the beginning. That's the left, so that's a left strip. It all takes any, if there's nothing there, it doesn't harm it. R strip means throw away all the blanks on the far end. And then strip says go take both sides for strip, and so that pulls out all the spaces on both sides. This will be useful because sometimes when you're tearing stuff apart, you'll find yourself getting extra spaces. Sometimes at the beginning, sometimes at the end. And it can be tab or new line. It's sort of white space that is kind of not visible, clear. That's what white space is. It's like if you were on a piece of paper,
yeah,
it's the white space. It's like,
yeah, if you don't know what white space is, it's just any space, really. Like he said, it's if we tabbed it over, where's the thing? If we this is all white space right here. This is white space. This actual break from here to here, that's white space, but also the break, this from here to here, that's a white space too, right? So let's go.
X, well, that's not white space, but right here, oh, that's white space. It's any character that doesn't cause printing to happen, if that makes any sense. It's any character where nothing would be printed. And
we could just look
like that. There's like even bell characters, but we don't use them very much. We can ask a very...
All right, so let's do this one. We've still got quite a ways to go. All right. Prefixes. Let's do that. Prefixes. Okay. So this would be like, what? 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 What are we doing here? Line. So let's just type this out. So line equals, please have a nice day. Okay. When we come down here, we say line dot starts with please. All right. Let's cap it off like that. And this thing is going to evaluate to true with a capital T, true, because it's Python. And when we do line dot starts with, and then we have lowercase p right here, it's going to be false because it knows there in Python there is a difference between these two characters. This is uppercase and this is lowercase, so this is going to be false. Okay, and if we did like, anyway, so there we go. Let's listen to him talk about it.
Conveniently, we can say, hey, does this line start with a particular string? And so, you know, line, does this, this is a question, going to return a true or a false. Does this line
It's
start
not
with
a
please?
question.
And the answer is
Look, these are not questions. These are statements. Okay, it's a statement, and this thing is agreeing with us. It's not we're not asking it anything. We don't ask computers anything. Okay, we can in ChatGPT, but the only reason it knows to answer question style or answer style, let's say, is because somebody told it to. You know, it's not actually. They don't answer questions. Don't ever think that computers answer questions. They do what we tell them to do. They are not human. There's nothing soul having about them. Okay, they're just machines.
true, it does start with please. Does this line start with a lowercase p? No, it does not. And so again, you'll use this in the context of if something colon.
Hey Hammer, do you want to hit the nail today? No, I don't. I want to take a day off. Shut up. Yeah, that's not how it works. We tell them what to do. The reason we're polite and ask people things is because there's a chance that they will say no, and we don't want to say, hey, do this, and then they say no, and we get embarrassed or mad at them, right? Machines are not people.
Some block of text, some block of code. So we can combine these.
So let's do this. Parsing and extracting. We're going to do this. I don't really know about it though. So let's just type it down and then he'll explain it to us. So let's do that. Parsing and extracting. All right. All right. So we've got this from. So let's do this example. From Steven dot doesn't matter at dot no, not like that at amazon.box.com, whatever, sat jan and then 2 spaces 5 09 14 16 2008. Okay, so what we got here is we say data equals, and then we'll put in here this stuff. All right, let's grab this. Data equals this. At position equals data dot find. Let's go find the at like this. Okay. Then we say print at position, and it's going to give us position 21. All right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's act like, all right, what was it? Steven out 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. There we go. All right. So it's at, so this at sign is at position 21. Okay. So when we say space position, SP position equals data dot find and then we look for a space at posts. All right. So it's going to go from here to, it's going to look in between here and what? Hold on. Oh, is it going to start at posts? There's no, yeah. So it's not going to check this space. It's going to start here. Okay, cool. So when we say print S posts, oops. When we say print S space position, we're going to get 31 because it starts at post. I imagine that's what it's going to say. All right. So it doesn't get this space. It gets this space, which is at 31. And then we say host equals data. All right. We've got some brackets. And inside the brackets, we've got at posts, at position +1. And then S posts. I wonder what that's going to do. Oh, so it starts at this one. So it starts here at the U and then goes to the space, but not including the space. So it's just like a slice when we do the print. So print host equals. Also, it wouldn't be at 31. Let's say amma dot bx dot co. Okay, so that would be 31, right? How about that? All right, so when we print this thing, when we print host, okay, it's going to give us. Should have just did what he did, but whatever. It's going to give us amma.bx.co like that. All right. And there we go. That's basically it. Looks pretty cut and dry. So I don't know why it says parsing, but he'll tell us about that.
Things to tear stuff out. And so let's assume that what we want to do in this case is we want to take a from line. This is from an email format from a mailbox. And this has got the from with a space and the person's email and then @ sign in the school they're from and a space and then the rest of the stuff like when this mail was sent. And this is a real mail message from this guy Stephen from the University of Cape Town in South Africa. And it's really Stephen, and this really is the first line of a file that you'll get to know pretty well by the rest of this course. Hi Stephen, we like you. You are the example in my class and have been for a long time. People actually who know Stephen have taken this class and they're like, Stephen, I saw your picture in the class. So if you're ever in Cape Town at the University of Cape Town, say hi to Stephen and tell him that you saw him in the class. But okay, that's neither here nor there. What I really want to do is I want to extract his school from this email line. Okay, so now eventually we will do things like the data will come from files, but this is still chapter 6. So this is the data we're going to search through. And so we can say, hey, let's go find the @ sign. Search up to this position and find the @ sign. So data.find @ sign. And give me back where that's at. That's in position 21. This is position 0. Then what we're going to do is we're going to look for the next space after the @ sign. So we're going to start at the @ sign and tell find to start here and look forward until it finds a space. So data.find, look for a space starting at the position of the @ sign, and then that'll be in position 31. So 31 is what we get in the space position. So now what we have is we have in two variables, we have position, the position of the @ sign and the position of the space after the @ sign. Now what we really want is this bit right here. So we have to go one beyond the @ sign, and we don't want the space. So we say, we're going to use slicing here, data sub at position +1 up to but not including the space. Oh, smiley face, because we didn't have to say space -1 because that is up to but not including. And so we get.
All right, so yeah, let's look at this again, even though we already looked at it. So this can be written inside of a function. and can be used over and over and over again. So let's say it's Jimmy.James at Amazon.com or whatever. Okay, it'll always look for an at, and then if it's a from line like this, there's always going to be a space after the website's after the web address. Okay, so even if it's a million letters at a millionletters.com space Saturday, whatever day today is, it will know that after the at and before the space, all that is the email. Is the website that this email is associated with. I don't know. Let's go.
Get that little bit right there. So we don't have to say -1 there, because this is not actually included. The thing that's at the position of the space is not included. So that's already a little benefit for the up to but not including. And so when we print this variable out, host, we get exactly just the school that Stephen works at and probably went to, as a matter of fact. I don't know if he went there or not. So this is just...
All right, so here's this. Let's not type this down. Okay, so I don't know why this is, but we got Python 3.5.1, x equals some Korean, type x. It's a class string, type u of this. I don't know what that is. What? So x equals u with this stuff. Type of x is string. So in Python, old Python, what? All right, so here's x is the Korean, type x is string. If we put a u in front of it and say type x, it says Unicode. Okay, so it used to be Unicode to do this, but now it's string. In Python 3, all strings are Unicode. Okay, so this is Unicode and this is Unicode in Python 3, but in Python 2, this is actually a string and this is Unicode when you do this. Okay, all right, we'll see.
A note for non-Latin character sets, all programming languages from the 60s on tended to work in what we call the Latin character set, which is the United States and England and Europe, and lots of places use this ABC character set and the special characters. But it's really common to want to use different characters. And so if you're going from Python 2 to Python 3, and we'll talk about this a little later when it matters more, luckily we're in Python 3, and so one of the big things about Python 3 is that all the internal strings are Unicode. In Python 2, there was sort of some confusion as you went between strings. And this is just a little bit of code, and so I'm putting in here, some Asian characters. This is Korean, actually. Asian characters into X, and then I say what kind of a thing this is, and that is a string. And then there's this Unicode, and this comes from Python 2. If it's a Unicode operation, it's still a string. Whereas in Python 2, if you put international characters into X, then it was a string, and then there was a separate kind of a constant called a Unicode constant, and it was a different type. And there was ways that you had to mess with these Unicode variables as you did things like read them from files and put them back into files and did other things. So it was much more difficult in Python 2, but we're doing in Python 3, and in Python 3 it natively understands non-Latin character sets, international Asian character sets, Spanish, French character sets. And so this is a good thing for Python 3, and this is one of the real benefits of using Python 3. And as we start doing stuff where we're exchanging data with the outside world, this will come into play, and I'll have to show you how to use it. There was weird things that you had to do. It just makes a lot more sense in Python 3. Okay?
Okay.
So we've talked about strings.
A summary. That means we're about to be onto exercises. So let's type out this summary real quick. That's real quick. All right, so let's do this. Let's do a summary real quick. All right, so summary. So we've got string type, right? The types of strings there are. Let's do an ergo, e.g. Ergo Unicode 8. you hold on. Unicode, hold on. Okay, Unicode 16, etc. Not that we've gone over those or whatever. Anyway, so let's go to the next one. Read/convert. I don't even think we really went over that, but let's take a guess. Reading data and converting it to types, to useful types. Types, question mark, because I don't know if that's what he's going to say. Indexing strings with brackets, all right? Using bracket notation to access strings using the indices, whatever. Either way. Slicing strings like this. So we have like 2, 4. So let's put the S in front of it too. I think that's how it was done, right? Is that? I don't know. Let's go. We just did it, so let's go look. Shipping, search and replace, making the searching strings. Here we go. All right, so yeah, it's S like this. Okay, so let's do that. Slicing strings, where the S tells, hold on, let's do this. Where the S tells Python a slice is in order. The first number is where this is the index. The index where the slice starts. And let's drop this down. Let's tab it. And the second number after the colon is the index up to, but not included in the slice. Okay, great. So let's do the next one. Looping through strings. Let's do this too. All right. Looping through strings with for and while. Did we even go through that? Hold on. Looping through strings. Did we go through for and while? Yeah. No. We didn't really go through it, but whatever. We'll type it out anyway. So looping through strings with for and while, using for loops to loop through strings. I guess. Okay. Let's put a question mark on the end of that. Concatenating strings with the plus operator. Okay. And then using combines strings using the plus sign. Okay. What else do we got? String operations. What was that? Let's go look at the notes. String operations. We didn't really talk about. Oh, here's looping. Okay, yeah. So we've got that. Strings. What was it? String operations. What was that? Searching a string, search library, string comparison. Using in as a local op. Okay. String operations. I don't know. I don't even know. Calm down. I don't remember. So let's just make something up and then let him tell us. String operations. I bet it has something to do with operations that have to do operations done on strings. All right. Anyway, let's go to the next one. We'll fix that one up when he tells us. So now we're going to do string comparisons. All right. Using UTF-16, Unicode and UTF-16, same thing. Okay. Using UTF-16 to compare the values of strings. Okay. And then we got searching in strings. Okay. Using the find method. Okay. Then we got replacing text using the replace method. Okay. And then stripping white space. So that's using the strip, lstrip, and rstrip methods. All right, now let's see what he says. Remember, we got string library too. String comparisons, string operations. We'll do string library. The list of built-in string functions. Okay, now let's listen.
About the string, we're converting it. We've done a whole bunch of stuff, and this is again, we're not yet doing anything super useful. We're learning sort of how to like slice and dice, even though we're sort of not making the meal yet. Up next, we're going to talk about files. We're going to read some data, and we're going to slice and dice and use all the things in the next chapter that we've learned up to this point. So see you in a bit.
All right. So you didn't even go over string operations, whatever. So I'm pretty sure that string operations is probably the same thing as done on string operations. Probably the same thing as let's put some stars. Let's put the question marks. Let's put the stars. Probably the same as built-in functions. I don't know, honestly. Let's just leave operations done on strings. That's good enough. All right, so there's that. We're finished with that. We're going to do the exercise in the next video. God, this is going to be so long. I have to watch the whole thing to make sure I didn't say anything too incredibly stupid. So trust me, if you think it's long, I had to watch the whole thing after making it. So it's like double boring. All right. So anyway, guys, we're going to do that. We're going to do exercise in the next video, and we'll see you next time.